Hello and welcome back to this tutorial series on Introduction to MATLAB. In the last tutorial, I solved some of the practice problems by using the concept I have discussed till now. Along with that, I introduced the disp command, which can be used to display the result into command window as per requirement. Till now, we have seen how to create vectors and matrices in the MATLAB and performed the different operations on this. In this tutorial, I am going to discuss how we can use these operations to solve the system of linear equation. Let's get started. So to solve the system of linear equation into the MATLAB, let's first look at these three generalized linear equations, which is the first equation is a1x plus b1y plus c1z is equals to d1, where a1, b1 and c1 are the coefficients and x, y and z are the variables. Similarly, if you see in the second equation, you have a2x plus b2y plus c2z is equal to d2, and in the third equation we have a3x, b3y plus c3z is equal to d3. So these a, b and c are the coefficients of these variables x, y and z. On the right hand side of these equations we have d1, d2 and d3. These are some constant values. So to solve this system of linear equations into the MATLAB, what we have to do is first we have to convert them into some matrix and vector format. So I'm going to create a matrix A which contains all the coefficients in it. So this first row, which contains a1, b1 and c1, it contains the coefficient which correspond to the equation 1. If you see the equation 1, we have a1, b1 and c1 coefficients for the x, y and z. So I'm going to write these into the first row. Similarly, from second equation, the coefficients are a2, b2 and c2. So these a2, b2 and c2 will be written in the second row. Similarly, we have the third row coefficient which correspond to this third equation. Next, we are going to create a vector x which contains all these variables in column vector. So I will create this capital X as a column vector which contains these variables x, y and z, and finally these constants t1, d2 and d3 I am storing it in another vector which I called as small letter d. So d1, d2 and d3 are the constants which are placed on the right hand side of these equations. So that means if we create these matrices and vectors, we can write a times x equal to d. That means this, if I multiply this coefficient matrix with this column vector x, then I equate it with this d column vector, we will get these three equations back. Then we start substituting the value of a and the x and d. So a is coefficient matrix. This is also known as coefficient matrix because we have created this matrix using the coefficients from the equations 1, 2 and 3. So this a matrix is the coefficient matrix. Then we have this x column vector which contains the variable x, y and z, and then we finally have this d column vector which contains the constants t1, d2 and d3. Now if a matrix, which is coefficient matrix, is non-singular, that means a determinant of this matrix is non-zero, then we can find out the inverse of this matrix. And if we can find out the inverse, then we can find out the solution of these equations and we can find out the value of these variables x, y and z. So x can be written as, this x is a column vector, so I'm writing it as a capital X so that we can distinguish between the small letters x, small letter y and small letter z. So these are our variable. So I have written this capital X is equals to a inverse d. So we can find out the value of these x, y and z, and which are stored in this x column vector is equal to, given by this a inverse into d. So to solve that into MATLAB, let's look at simple two equations which has two variables x and y. So I have written 2x plus 5y is equal to 1 and 3x plus 2y is equal to 7. So this is my second equation. From equation 1 I will find out y in terms of x, so we get 1 minus 2x by 5. Then I am going to substitute this value of y in the equation 2 and I will get value of x. So x comes out to be 3. Once we have x value, we can substitute x into this y is equal to 1 minus 2x by 5. Then we will get y is equal to minus 1. So this is how we can solve it manually. To solve that system of equations into MATLAB, we have to convert them into matrix and vector format. So first we will create this matrix A, which is the coefficient matrix. So from equation 1, which has the coefficient 2 and 5, I will write them into the first row. Similarly, in the second row, 3, 2, I will write this element 3, 2 in the second row, which is from the second equation. Now I will create this x vector which is x and y, and then finally we have this d column vector 1 and 7. In the MATLAB we do not create this vector as a capital X equal to xy. We will just simply write this command x equal to inverse of a into d. The result obtained from this will be stored directly in this x column vector, so we do not need to create this x and y into the MATLAB. So let's move to the MATLAB and we will start writing these matrices and vectors into the MATLAB, and then we will get the variables x and y. So first I am going to create matrix A which contains the coefficients from the equation 1 and 2. So matrix A contains element 2, 5, 3, 2. So 2 and 5 are the coefficient from the equation 1. Now I will move to the next row and then I will write 3 and 2, which is the coefficient from the equation 2. If I press an enter key, a matrix A is created. Now next thing we have to do is we have to create this vector D, which is actually the right hand side of this equation. So D is 1 and 7. So I will create a column vector. For that I will use these square brackets and then I will supply the elements in these brackets. So 1, and then we have second row as just 7. So if I press an enter key, a vector D is created. Now we have to check first that if matrix A is non-singular or not. For that we have to find out the determinant of it. So to do that I will call this det command to calculate the determinant of matrix. A is a square matrix because it has 2 rows and 2 columns, so we can find out the determinant of it. So I will write determinant of A. If I press an enter key, we get this minus 11. So that means it's not 0. That means A is non-singular and matrix A is invertible. Now we just have to simply write capital X, which is our final answer, and I'm going to store the value of inverse A multiplied with D column vector into this X column vector. So it's going to be X column vector. If I press an enter key, you will see we have this X vector, which is a column vector, contains the value 3 and minus 1. And if I move here, you will see this capital X at the first row contains small x, and the second row it contains y. So the first value, this which is 3, is the value of x, small x, and this value of minus 1 is corresponding to the y. So x equal to 3 and y equal to minus 1. Let's look at 3 equations which are system of linear equations. So this is my first equation, which contains 3x minus 2y plus 3z is equal to 8. Second equation, 2x plus y minus z is equal to 1, and 4x minus 3y plus 2z is equal to 4 is third equation. So first we are going to create a coefficient matrix which is named as A. You can name it any name you want. So this matrix A contains, the first row is the coefficient from first equation, second row is the coefficient from the second equation, and the third row is the coefficient from the third equation. So if I move to the MATLAB, then I am going to enter these values and going to create a matrix A. So A matrix is, the first row contains 3 minus 2 and 3. Second row contains the coefficient from the second equation, so 2, 1, minus 1, and then last one is 4, minus 3 and 2. Now I don't want to display this result into the command window, so I'm going to use semicolon outside of this bracket. That means it will not display the result into the command window. So if I press an enter key, a matrix A is created which contains these elements. You can simply go to the workspace and double click on this variable A, which is the matrix A, and a window will appear with the name variable of A, and this is my matrix, which is 3 cross 3. You see at the top 3 cross 3 matrix. That means it is again a square matrix. Next I'm going to create a vector D which contains the elements from the right hand side of these equations, so 8, 1 and 4, which is going to be placed in the column vector. So 8, 1, and then I will like 4. If I press an enter key, before that I will use semicolon outside of that, so I don't want to display the result in the command window. Now we have A matrix and now we have D column vector. First we check if the determinant of A is 0 or non-zero. If I press an enter key, it says minus 17. That means its determinant is non-zero and matrix A is non-singular and its inverse exists. Now we just have to store the answer which we will obtain using inverse of A times D into this X column vector. If I press an enter key, X column vector is created which contains the value 1, 2 and 3, and these values correspond to the variables x, y and z respectively, because the first row correspond to the x, second row correspond to the y and third row correspond to the z. So these are the answer. So if you see these three equations, so x, y and z value, which is 1, 2 and 3, we obtained by solving this system of equations in the MATLAB, is satisfied by these three equations. So this x, y and z value will satisfy all these three equations. So this is how we can use the MATLAB to solve the system of linear equations. Right now we just saw only 2 and 3 equations. If you have multiple equations, 10 or 100 of linear equations, you can easily solve by creating these matrices A and this column vector D, and we just have to simply call this command x is equal to inverse of A times D. Inverse of A is only existed if determinant of A is non-zero. Thanks for watching this tutorial. If you like this tutorial, please like, share and subscribe. I will see you in the next tutorial.